Hi everybody, we are going to look at the three examples at the bottom of the notes. This says constant times functions. What I want you to realize is it's this. It's really the power rule multiplied by the coefficient, or when you're using a coefficient in front. All right, so for number one, take a look here, and I believe we've talked about this. If you have a function of s, then it's going to be the derivative of the function s. If your input is t, then it's going to be with respect to t. So this will be the notation that you will be using to make sure that we're talking about the right output function and the right input function. So here's what we do. Gets multiplied, that power gets multiplied by that coefficient, and we subtract 1. So the derivative of the function s with respect to t, the -3 times the -4, gives us 12, and a -3 minus a 1 gives us -4. Remember, we want to make this positive. This goes to the denominator and becomes a positive exponent. So we would have 12 and 1 over x to the 4th. And the most efficient, mathematically correct way to write that is 12 over x to the 4th. That's number one. Okie dokie, number two. Here is something that you just need to realize. What is the power of just an x? It is a 1. So if we're taking the derivative of this, we are multiplying the 1 times the 3/5, and then we're subtracting 1. So the derivative would be the 1 times the 3/5, and then x to the 0. Now if you recall, x to the 0 is 1. So our final answer would just be 3/5. All right, example number 3. Here we go. This x to the 1 needs to move up to the numerator. And what do our exponent properties tell us to do? That would be a -1. So in this case, the y prime, or the derivative, we're multiplying it by the 10, the coefficient in front, and subtracting 1. So we get -10 x to the -2. What happens? This moves down to become positive. So we have -10 and 1 over x squared. And then, of course, we need to write it the most efficient way, which is -10 over x squared. All right, see you guys next time.